This week, Anthropic released an update to Claude 2. They introduced Claude 2.1. So it's a latest model, and it's available over API. The biggest thing that they did with this model is that they increased the token context window to 200k. Now, for Claude 2, the context window was 100k. Now, they did mention in their paper that it did have the capability to do 200k tokens, but they actually limited it to 100k. So they didn't have to retrain a new base model. So this was already in there. What they've just done is they've increased the context window, and then they did some fine-tuning to make it more safer. Now, of course, when you make it more safer, this can hamper performance. So we'll go down and mainly they just give us some tidbits about how they made the model safer and more accurate. So we'll look into that. And then also, of course, when you make a larger context window, it's quite cool, but there's a huge problem with this. So in the video I made with Claude 2, if you watch it, I also covered another paper that came out around the same time. This was the paper Lost in the Middle. So as you can see, what this paper basically entails is that making context windows for these large language models is pretty much redundant, because what ends up happening is it retrieves the information very well in the beginning and somewhat well in the end, and in the middle is just in tatters. So this is the biggest issue with extending the context window. And now, of course, there's solutions to this. We have RAG, Retrieval Augmented Generation, where you have an extended knowledge. You store things separately, and then the model can just retrieve things from a vector database. Now, there was someone on X named Greg Camrad who did all of this for us. He managed to test the performance of Claude 2.1, and this is what he came up with. So what he did was he had a Paul Graham essay, which he used to fill up the whole context window, the whole 200k context window, and then in each section, like in the beginning and the first 10%, the first 20%, the first 30%, as you can see, in each interval, he inputted a text. The text he inputted was, let's see if we can get it here, was this. So he put the best thing to do in San Francisco is to eat a sandwich and sit in Dolores Park on a sunny day. So he put this text on each interval in the input text and attempted to retrieve it. And now, as you can see, in the first 19k lengths, it's almost pretty much perfect, I would say. It's pretty good. It can retrieve this text at almost any interval, any depth that you see. It's called any depth in the document, it can retrieve it. But as soon as we get it to 24,000 and then we increasingly go, there's some shortfalls. And of course, this is where even in these cases, this is where we begin to use RAG, because in a very, very in a situation where information is very, very important and any inaccuracies can be detrimental, this is of course when you can't use an error rate of this size. This is why many people in enterprise, they are using RAG to resolve this. Now, as soon as you go to 83k, this is now when, not even 83k because it's quite similar, but as soon as you go to more 130 is when things just get ridiculous. It can't retrieve this text at any point at all. So, except in the beginning, of course, and in the ending. So, this characteristic that these models have, there's still so much talk on why it just mainly does the beginning and the end. I remember there was one paper that was suggesting it's because this is how the attention mechanism works, and of course, if you're modeling data, typically if you're reading a book, if you know the beginning and the ending of the book, you know a decent amount of what's taking place in the book, and you can sort of generalize from that. So maybe this is something that's been imbued in the models through transformer architecture that we're using today. Yeah, I mean, this is a strange phenomenon. So, of course, again, this is with Claude 2.1, guys. So this situation is not resolved by any stretch of the imagination, but it is resolved if we're using RAGs or vector databases to maintain 100% accuracy. But the issue with the RAG is that it's very computer intensive, of course, and you can see here just him running this test. It cost $1,000 just to run this test for us. So big props to Greg for doing this. Now, yeah, that's just the biggest issue. So there seems to be no fine-cut or clear-cut solution to this. But anyway, let's go back to the web page. So this is the context window. Let's see what they did in terms of safety on their Claude 2 paper. So if you go all the way down to the appendix of the Claude 2 paper, they've now added an additional section called Claude 2.1 Model Card Appendix. So, okay, so let's dive in here. Now again, they mentioned the 200K context window. They did come up with their own benchmarks here, and they're not as you see, this is the thing, you know, like they didn't provide much information on how they conducted these long context benchmarks that they ran here. Unlike Greg gave a YouTube video. He gave a very comprehensive analysis and graph on the accuracy of this longer context length. But here they didn't give us any experimental details on how it was done, which it sucks. So. But anyway, as you can see, just looking at the average, they are just showing this overall improvements. Now, and then of course, again, just seeing here, the beginning and the ending again is just the most reliable, and then the middle is the most unreliable. And the gains, strangely, the gains between 2.0 and 2.1 is very minuscule for the ending. But anyway, so here's the honesty evaluation. And again, even the Claude 2 paper was mainly filled with honesty evaluations. So let's dive in. So they say they're under factual accuracy. They said that they tested Claude 2.1's honesty by creating a large set of complex factual questions that probe known weaknesses in current models. So they using a rubric that distinguishes incorrect claims. The fifth most populous city in Bolivia is Montero from admissions of uncertainty. I'm not sure what the fifth most populous city in Bolivia is, and they say Claude 2 is more significantly more likely to demur rather than provide incorrect information. So they've lobotomized it even more. So it's good news, I guess. Now, faithfulness for long documents. So here they try to measure the factual retrieval abilities of the model in long documents, provided like long documents where they can reference them properly. So here, and then they said with Claude 2.1 there was a demonstrated 30% reduction in incorrect answers, a 3 to 4% lower rate of a 3 to 4% lower rate of mistakenly concluding a document supports a particular claim. So here we can see the difference. There's a huge deduction in inaccuracies, but there's a huge increase in declines to answer. So whether this decline to answer is even going to be minimal questions such as if you can ask it to kill a Python program for you and then won't be able to answer. These are the questions, but it's great that we're exploring better, or we're exploring this pathway of increasing the context window. Sooner or later, we're gonna have a model with a million context length. I'm sure. How you do that, I don't know, because I can't imagine like the inferencing. It's gonna be ridiculous. But again, there's so many workarounds for the context window. That some might argue that even a 200K context window is a bit overkill. But here we are. So yeah, that's it. Thanks for watching.